something else is slowing us down. What could it be? So our code doesn't have any instrumentation. I didn't do like a full guided tour of the code, but if you look at each microservices, like the most complicated one is like 50 lines of code, including commands and blank lines and imports and everything. So it's like super simple. So instead, we are going to use state-of-the-art like HTTP benchmarking tools. In that case, we're going to use HTTP ping, which is exactly like ping, except instead of using ICMP packets, it just do simple HTTP GET request, and then it times this request, so it gives you kind of response time for the server. And we're going to benchmark the individual microservices in this application. Like specifically, there is this random number generator and this hasher service. They are exposed on port 8001 and 8002. Like if I do a Docker Compose PS, I'm going to see that. Well, I have too much workers now. That will teach me. I can see like RNG is exposed on port 8001 and hasher, which is a little bit above, on 8002, which means I can directly talk to them if I want. I can do like curl localhost 8001, and this tells me RNG running in such container. 8002 tells me hasher is running there. All right, so I'm going to use HTTP ping localhost 8001. So this is RNG, and RNG responds in like 1.7 seconds, which for a locally hosted web service is not very good. Just as a comparison, let's check how hasher is doing. So same request, but on hasher. 1 millisecond. That's way more in line with like requests on the local web server. So RNG seems to be responsible for what we are seeing. We could do like a whole benchmark campaign with Apache Bench and audit the code and whatever, but nobody got time for that. So we're going to draw like a super hasty conclusions. We're going to say, oh, I know, I read something about entropy and /def/random in login 10 years ago, and it's probably that the problem is that when you need to come up with random numbers, you need entropy, and you get entropy by moving the mouse and using the keyboard and also like the disk6 and so on. And so the problem is probably that we don't have enough entropy. It's totally wrong. That's not the problem, because we're using /dev/urandom and not /dev/random. And by the way, there is no good reason to use /dev/random. And if you don't trust me, follow the link here and you will see it. Super good explanation why /dev/random should not be used. But anyway, we're going to pretend that indeed, yeah, we need more entropy, and so the only way to get more entropy is to scale the RNG service across multiple machines. It's a fiction, but it's a convenient fiction that gives us a nice excuse to scale our application. So before moving forward, we are going to remove all those containers with Docker Compose down. So you have like Docker Compose stop, which stops the containers, Docker Compose kill, which immediately kills them, like without this 10 seconds grace period, and Docker Compose RM removes the container, and Docker Compose down does the whole thing, like stop, kill the laggards, and then remove the containers and remove the other resources. Like in that case, there was a private network created for our application, and Docker Compose down took care of removing that private network at the end.